All righty.
I already tied my shoes in like a triple knot and hung over them in my room. It's gonna be so fun though. Michael, I don't like losing.
So, today we're going to be continuing along with what we had started on Friday. Okay, so we're not going to be learning, well, I know we are going to learn one new test, I guess I'll say, yes. And then we'll kind of get some practice in. So we're going to continue looking at our infinite series stuff. Remember, we only really have one way to determine if a sequence, we have one kind of test we really have named so far, I guess I'll say, and that's the geometric series there. Okay, and we can find if a geometric series converges or diverges, and it all depends on whether the absolute value of that common ratio is less than 1, the series converges. If the absolute value of your common ratio is greater than or equal to 1, the series diverges, right? And then even more special, as we're going to find as we go here, if we know the series converges, we can actually find the sum of the series of an infinite number of things. We'll be able to find what the final sum will be. Okay? But, and we went through a bunch of examples there and stuff like that too. Okay? All right, so we're going to continue on here and look at some properties then of infinite series. All right, so again, we normally introduce something brand new and we look at the properties of it, right? We talked about limits, and limits had properties attached to them. We talked about derivatives, and derivatives had properties attached to them, so on and so forth, even integrals too. And now we have this new operation with the infinite series, and of course there are properties attached to that. So let's let the sum of the sequence a sub n be equal to just the limit here a, right? It's got this final sum, and then also the sum of b sub n, be capital B, and then c is a real number, like a constant or a coefficient, right? Then the sum from 1 to infinity of c, the coefficient there, times the sequence, right, is equal to just c then times the final sum. Okay, right? So if you have that lead, that lead coefficient, you can kind of just multiply the final sum by that too. Likewise, if you add two sequences together, okay, and if both of those, are finite series, then they'll also, you can just add up their final answers there, the a plus the b, and likewise with the difference too. If you have two, again, subtract them, then you can subtract their final answers as well. Okay, so what is that going to be useful for? Well, if you look here at example 5, right, in example 5 here, we've got 3 kind of things being combined together here through addition and subtraction. And rather than trying to find the sum of all 3 of these together, we can break it up into pieces and allow us to solve from there. Okay, so I'm going to kind of divide my paper up here into 3 sections, okay, just so we can kind of, take care of one piece at a time. So let's focus on kind of evaluating, this one, and then this one, and then this one right here. Okay, so we'll focus on that first one here. I'll zoom in some. All right. So we're just going to define the sum from n equals 1 to infinity of 3 times 4 to the negative n. Okay. So what kind of series does it look like this might be here? It looks like it might be geometric, okay? But what's our common ratio going to be here? 1/4, right. So let me just show that to you here, maybe make it a little more obvious. Okay, right? When we have 4 to the negative n, that's the same thing as saying 3 times 1/4 to the positive n. Right? If we take that kind of negative 1 out of the n there and make a negative 1 power, 4 to the negative 1 will be 1/4. And so that's where we can really see, okay, what's going on here and stuff like that. Okay? So in this case, right, is this geometric series, are we expected to converge or diverge? Converge, right, because the absolute value of 1/4 is less than 1. Okay, and so we can just go ahead and find the sum of this, right? Let's see here. So the sum is going to be the first term, and what will the first term be here of this series? 3/4, right? 3 times 1/4 to the 1 over 1 minus, and then what is our common ratio here going to be? 1/4. You got it. Okay. And if I multiply the top and bottom by 4, that ends up being 3 over 4 minus 1, and so it's 3, over 3, which just simplifies to 1. Okay, that's pretty straightforward. All right. So the very first piece is equal to 1. All right, so let's try the second piece here. So for the second piece, we have the negative sign in front there. I'm going to pull that negative sign out front of the summation like this. Okay, so it's minus the sum, I'll say. from 1 to infinity of 2 times 1/5 to the n minus 1. Okay, and again, I did some manipulation. Oh, yeah, question. Oh, my gosh, I'm sorry, Richard.
There's no way. Because even if you were to get mad at Mike, and then like you could like walk over and look at his face.
I know. And then you bow down.
You can't even look at him. You can't. You're a kid.
I promise. Girls get yours.
What?
I said, I promise you though, girls get yours.
Dude, I learned my lesson. You don't guess a girl's weight.
But then you're not.
Okay, sorry about that. So, again, 2 times 1/5 to the n minus 1. What series does this look like? Is this geometric as well?
Yep.
It is, okay? And you might be like, Mr. Wade, we have n minus 1. That's okay. This still is showing repeated multiplication by that 1/5 here, okay? And so we're just going to, kind of proceed here. So again, it's r is less than, absolute value of r, sorry. Absolute value of r is less than 1/5. Oh, sorry, less than 1, not 1/5. 1/5 is the r. 1/5 is less than 1 there, okay? So what is our first term going to be? 2, yeah, or I'm going to put, let's see here, we should, but then there's going to be a negative sign in front of it, so we'll call that -2. Over, or you can say -2 if you wanted, yeah, anyway, yeah, -2 there. So, and then what is our common ratio here? 1/5, so 1 minus the 1/5 there, okay? We'll multiply everything by 5, so you get -10 over 5 minus the 1, in other words, -10 over 4 or -5 over 2, right, when you simplify there. So then this, right, just approaches -5 halves. So far this thing is going to be equal to 1 plus -5 halves, and then plus, and then we'll put this one here too. So why don't you guys go ahead and find the sum for that last one, okay? And I'll zoom it out here. So go ahead, take like a minute or so. Ooh. Well, yeah, that'd be good. Why isn't it n equal?
What is it?
Or why? Oh, I don't know why I put a -1 there. You're right. It should be +1. Yep, that was just me misreading. Yeah, it should be +1 there. So should have gotten 16/9 there, 16/9. Questions on any of those questions? Yes, Kara.
How did you get the -4 sign?
Yeah, so I did make a bit of a leap there, I realized when I was going through it. But, so what's the idea here, right? So we've got negative 4 to the n plus 1 over 5 to the n, which is not like a, it's a little less familiar, I'll say, right, for our geometric series. Normally we have like just a plain old number being raised to the n, but here we kind of have two numbers. One's being raised to the n plus 1, one's being raised to the n. So it's different powers. That can kind of throw us off a little bit here. So let me just kind of show you. I'll maybe do this part right over here above this piece right here. Maybe I'll go like right up in there. So, this is what we had, right? And I'll put the summation here too. Like that. And I'll zoom in some there too. Okay. And so really it would be nice, like the idea here would be really nice if we can just get the n's to be like the same power, right? If we get the same power. So something raised to the n plus 1 power, that's going to be equal to, and if you'll permit me here, I'll just like rewrite this thing here as, so negative 4 to the n times a negative 4. Right, to the 1, we'll say, something like that. Does that make sense how I broke it up like that? And then all over the 5 to the n. And now you can see how we can put those pieces together, right? The negative 4 and the 5 can go together. This negative 4 to the 1, we can just pull out front, and so there's the negative, so, you know, there's the negative 4 goes there, and then there, this piece goes right there like that. It becomes those two parts. Okay? All right. Other questions on that? So it is helpful sometimes to rewrite those. I mean, is it necessary in this case? Maybe not, right? Because you can see in both the numerator and denominator, they both have the exponent of n plus 1 or n, and you can see we're going to be repeatedly multiplying by the negative 4 in the numerator and the 5 in the denominator because they both, again, have that exponential there. Again, finding the first term is pretty easy. You just put the 1 in for n here, put the 1 in for n here, and that'll give you that 16/5 as well. So again, is it necessary to split it up like I did? Maybe not, right? But it might be helpful. Okay, at least be able to see it. So anyway, all right, so let's jump then to example 6, and here's that question I was talking about that we had in the homework that we hadn't gone over yet, but here's one like that as well in case you had some difficulty. So again, the directions here are a little bit different. It says find the values of x for which the following series converges. For these values, then write the sum of the series as a function of x. Okay, so looking at this, right, I'll zoom in here then on letter A. So we're going to find the sum from 1 to infinity of x to the n over 3 to the n, which I'm going to rewrite, again, just to make it a little bit more clear that it is geometric, as x over 3 to the n, like that, right? We can put them all together because they're under the same power. All right, so this is clearly what kind of series here? Geometric, right? So since the series is geometric, and we want it to converge. Okay? We want it to converge. Well, what is the rule or what is the requirement for a geometric series to converge? What must be true? R must be less than 1. The absolute value of R must be less than 1. What is our R in this series? X over 3, right? That is the thing that's being raised to the n, so we're repeatedly multiplying by x over 3's. Right? I mean, if we were to write this out, it would be x over 3, and then plus x squared over 9, and then plus x to the third over 27, plus dot, 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 you know, so on and so forth. And so we're repeatedly multiplying by x over 3's. That's our r. So we want the absolute value then of that r, the x over 3, to be less than 1. Okay, there's our statement. But of course, we want to solve for all the possible x values. To solve this, right, if you recall, okay, solving an absolute value inequality, you can kind of use the idea of absolute value, right? We understand it's a thing, it makes things positive, right? But what's the actual definition for absolute value? How distant from 0 or how far away it is from 0. Exactly right. So if we want something, so the distance of this thing, x over 3, we want that to be less than 1 away from 0. That means we want that x over 3 to be less than 1, right? Because that's if we go beyond 1 or beyond, that's going, you know, further away from 0 than 1. But also 1 in the opposite direction from 0, which is negative 1. So we want x over 3 to also be greater than negative 1. And so that creates this compound inequality. Okay? Where that x over 3 is between the two values there. Okay? So then we'll just solve. And so then what do we do to both sides here? All three sides, I guess you could say, to solve it. What should we do? Just, multiply by 3. So we get negative 3 less than x less than 3. Okay, and so there's our range of x's that would give us a solution there. Okay, and then we're going to find the actual sum of this series. Well, again, the sum, so I'll write that out one more time down here. Scoot it up here some too. That'd be helpful. Okay, to the end. Well, again, for the sum, it needs to be first term. So what will the first term of this series be? X over 3. And over 1 minus our common ratio, which we just said was x over 3. All right, now we could leave it like this, but most of the time, right, we don't leave fractions within fractions. It's just not as simple as it could be. So again, take those denominators, which are both 3, and multiply the top and bottom by 3 over 3, right, which is just 1, to make it a little bit easier. And so we end up with an x over 3 minus x, like that. And so there it would be our sum. There would be our sum. So whatever this x happens to be, right, if we pick some x between negative 3 and 3, then its sum, the sum of this geometric series would be, this x over 3 minus x. Okay? Questions on any of that? All right. Well, then how about you guys then try the next one? Okay, it's not too shabby. Similar in scope there, so give it a try. And I'll do the same. This time I won't write it up there. Okay. Yes. Oh, thanks.
It's all wrong. You just give it a 0.
Okay, that'd be easy to grade then. Thanks.
Just give it a 0, but make sure you accidentally put in a 26.
Accidentally put it 26 times. Or actually 10, because that's what I do.
Or a 10. I don't want to put it at 0.
Oh,
So we weren't just looking at that. Should be less than
yeah. Well, that's all right. Well, I was going to write on this paper, but I said that, so. So yes. Later, that's fine. That's fine, yeah. Yes, I understand.
Fall asleep.
Yeah, I know, I figured. All you future business leaders, gotta get your parties in too, your fun times, while you're working hard, packing that whip. Well, so, you wanna figure out what kind of series is this? So you can see going forward there, right, we have this quantity being raised to n, so that means this is gonna be repeatedly multiplied, right? And so we have a geometric series, we know that. And so what is our common ratio? What's the thing that we're multiplying by every time here? X minus root of 4, yeah. X minus root of 4. Whole quantity is being raised to n, so it's that quantity. So that's your common ratio. So just like we did here, we took our common ratio, as the value of it less than 1. And solve that inequality. And now these are starting, because you're also supposed to work on sum with you.
Less than 1. You have a solving inequality with that value.
So the first term,
It has to be less
be careful.
than 1, but it has to be greater than the opposite one. So it has to be
good to me. It's set up correctly, so then what I would suggest, or wait, your first term here, be careful.
Yeah.
So make it 0.
I know that his styles of practice are get in, get out at 4:30.
Yes.
I was like, that's tempting.
For the answer, would that be?
He was like, you should.
Yes, it'd be the sum. Yeah, sorry, I think I wrote that up there.
Hour, 2 hours. and
Yeah, if you see, put the equal sign.
Okay.
And I'll have
I
it.
didn't.
Yeah, well, if you missed it, other people might have too. I want to make sure we're okay with that. Okay,
I don't know if that's right.
like 30 more seconds here, and we're going to go over this. 30 more seconds.
Or we'll have to figure it out.
30 more seconds.
The Wii song?
What was that?
Is it the Wii song?
Maybe, I don't know. I just made it up in my head, but you know, sometimes I have these.
Pretty sure it was the Wii song.
He's very talented.
Yeah, yeah.
Like Fortnite on the phone.
I can't get on the addicted. That would be my life.
Wait, they have one?
Good choice.
Yeah, it's about to,
They're releasing. Yeah, they're releasing a Fortnite app. Like,
Dude, I can't wait.
Suddenly, thousands of grades plummeted to 0. All right, so here's letter B. All right. -1 to 7 is the range for your x's, okay, for this thing to converge. And then 16 over 7 minus x is what I simplified it to be here. Be very careful that n equals 0. Okay, right? We kind of like, normally it's either 0 or 1. Mostly 1, but sometimes it's 0 for that first term. So be careful, right? Always check back to your original thing here, your original problem, I guess, to check what that first term would be. You plug the 0 in, so then 4 is your first term, just 4. Okay, so that gives you the 4a sub 1 over, and then 1 minus the common ratio there, and then simplify. All right. Questions on any of that? All right, and just to make sure, an example 5. Remember.
That-
Oh, sorry. Yep. Mhm.
what was the last?
That's okay.
Thank you.
And then also just real quick, going back to example 5, I just want to make sure, right? We solved for these 3 values, but of course they were the 3 individual parts of this sum. You add those 3 things together there to get your final answer, right? So you want to put them all back together, of course, and not just circle them individually, but combine them back together for the final answer. That's what we want. Okay? All right. Any other questions before we move on here? We're going to learn another little test. No? Okay. So this next one we're going to learn is called the nth term test for divergence. On the wrong side here. Here we go. Okay. So as a review here, what we're going to do is find the limit of each sequence and then determine the convergence of the following series. Okay, so we'll start, real basic here. Again, I'm going to kind of like divide the paper up into 3 sections here. And then since we're doing both a sequence and a series, I'm going to divide those further in half. So we'll have one part for the sequence, one part for the series. Okay. So the first thing it asks to do is find the limit of each sequence. So the sequence here, the sequence is just 2, right? It's going to be like, the sequence a sub n here is just 2, which means it'll be, 2, 2, 2, 2 in the sequence. Remember, sequence, right, is just the list of the numbers there, okay? So sequence is just going to be 2, and so we're going to take the limit then of that sequence, which is going to be the limit as n approaches infinity of just plain old 2. Well, what is the limit as n approaches infinity of 2? It's 2. So we say the sequence, what? Converges or diverges? Converges, right? It goes to a number, yeah. So the sequence, again, the sequence, remember, is a list of the numbers. Converges to 2. Okay, sequence converges to 2. Let's take a look then at the series, right? The series then would be the sum from n equals 1 to infinity of 2. And what would that series look like? What would our first term in that series look like? 2, and then we're going to add 2, and then plus 2, plus 2, plus so on and so forth, right? Well, without having to really apply any sort of test or anything like that, what do we know about this sum? It will what? it will diverge, right? We're just going to keep adding 2 to this thing, and so it's just going to go on to infinity, without ever approaching anything. Bless you. Okay? Excuse me. Okay, so let's take a look at this next series and sequence here. So we'll consider the sequence, which is just 2 times the quantity 4/3 to the n. We'll again take the limit as n approaches infinity of the sequence here. So 2 4/3 to the n. Okay. You can imagine here again, imagine substituting in infinity here for n. We're going to take that 4/3 and raise it to the infinite power. So we're going to multiply 4/3 by itself an infinite number of times, and then times 2. What do we expect this to approach? We expect it to approach infinity, and so it will diverge. Okay, so again, this sequence we expect to diverge. Diverges. Okay. What about the series? What kind of series is this?
Geometric.
It is geometric. Okay, what's our common ratio? 4/3, and so we would expect the series to, bless you. Our common ratio is greater than or equal to 1, so it's going to diverge. Diverge.
That's what I thought.
That's right. Just trying to test me, huh?
Exactly.
Very good. Keep me on my toes. Okay, so it's greater than or equal to 1, so the series diverges. Okay, that's your R there. Okay. All right, let's take a look at this last one then. So the last one, well, we have a sequence here, right? So the sequence is the limit. We're going to take the limit of the sequence. So we'll take the limit as n approaches infinity of 3n over 5n plus 4. Okay? And if we sub in the infinity, we're going to get infinity over infinity here, which is indeterminate. But we can apply L'Hopital. Okay, so I'm going to squeeze that little phrase in there. Apply L'Hopital. Okay, so that will leave us then with the limit as n approaches infinity of 3 over 5, which then that limit is just going to be 3/5, right? So we get 3/5 is our limit there. So the series, sorry, not the series, the sequence, the list of numbers will eventually converge to 3/5. Okay, so the further out we go in our list of numbers there, right, it's not going to start at 3/5. Right, if you plug in 1, it's going to be, what, 3 over 9, so it'll be 1/3. Make sure I did that right. Yep, 3 over 9, 1/3. So it's going to start at 1/3, comma, another number, but as you go way far out, it's going to get closer and closer and closer to that 3/5. Okay, and eventually it'll become so close, bless you, it'll become so close that it'll be kind of indistinguishable, right? So that's our sequence, all right, but then the sum of this thing. So, question.
Did you have to do all that, or could you just say that because they're the same power?
Same degrees, you're saying, and then you use the ratio of the lead coefficients? That is a good question. I want to say yes, but I'm not sure about that. So I'll check on that, though. That's a good question. About whether you have to apply L'Hopital's, or you can just see Mr. Witt, degree of the top is the same degree as the bottom. It's a rational function, so it's just going to be the ratio of the lead coefficients. You know, I don't know. I'm not sure. So I'll ask about that, though. That's a good question. Okay. And then, but here on the bottom, though, right? So let's go to now the sum of this sequence. So now we have to think, all right, we're going to take that series, we're going to take the sequence we just talked about up here that starts at 1/3, and we're going to add and add and add and add and add, and eventually we're just going to be adding a bunch of like 3/5, right? Because the sequence converges to 3/5. So that list of things that we're adding up, it's eventually just going to be 3/5 plus 3/5 plus 3/5 plus 3/5, you know, kind of getting closer and closer to that 3/5 there. Essentially just always adding the 3/5. All right? And so we have to figure out what this thing will do, right? Because is this geometric? Are we repeatedly multiplying by the same number every time? No, we're not here. We're not, right? This is not 3 to the n. This is not 5 to the n. It's 3 times n over 5 times n plus 4. Again, if you don't believe me, you can write out a few of the fractions here. Okay, and you'll see that we're not multiplying the same number every time, and so it's not a common ratio, right? The very first term we said would be 3 over 9, and I'll leave it that way. And then plus 2, so it's going to be what? 6 over 10, 14, plus, and then so on and so forth. I guess I should do maybe one more here, so we'll do 3. So, 9 over, and then 15 plus 4 is 19. Okay, and so you can see here, to get from 3 to 6, well, you can multiply that by 2, but then 2 times 6 doesn't give you 9, right? And then 9 times something gives you 14, but then that same thing that you're multiplying gives you 14 to 19. It just doesn't quite work out. This is not geometric. So how can we determine, though, what this thing does? Okay, well, does anyone have any idea about whether it diverges or converges here? It's going to diverge. It will diverge, okay? Series will diverge, okay? And so what tells us here this thing is going to diverge? Well, remember that our sequence approaches 3/5. So that list of numbers is going to get closer and closer and closer to 3/5, which means the sum, the series, right? We're going to eventually just keep adding 3/5, adding 3/5, adding 3/5. And that's going to increase the value of that sum, without bound. It's going to diverge, right? It has to diverge because we're approaching that 3/5. Okay? So, yes, question, Gabe?
Can you really quickly, how is it not geometric again? Because you couldn't factor out the n, basically?
Because if you look at, so there are a couple ways you can think about it. So, what makes a series or a sequence geometric? It is that from one term to the next, right, you have to multiply by that common ratio. And if you look here, there is no common ratio that gets you there. How do we see it show up just in the series itself? Well, there's no exponent, right? Exponents show repeated multiplication. This is just 3 times n. This is over 5 times n plus 4. Whereas, over here, it was 4/3 to the n power, right? So there. All right, so these results then, if we put these things together, allows us to kind of establish the nth term test for divergence, okay? And it's super important that we use this full phrase, nth term test for divergence, when we're discussing it, okay? And you're going to want to, the tendency, right, is to just kind of shorten up and call this thing the nth term test, right? Just like we call the geometric series test. But I would really recommend that every time you refer to this thing, you refer to it, because I will be too, refer to it as the nth term test for divergence. And I'll explain why I would suggest you do that. I'll explain why in just a little bit here. So here's what this test for divergence states. For a series, right here, the sum from 1 to infinity of a sub n, if the limit as n approaches infinity of the sequence does not equal 0, then the series diverges. Okay? So for a series, if you're trying to find the sum from 1 to infinity of a sub n, if the limit as n approaches infinity of the sequence does not equal 0, then the series diverges. Okay? So your sequence must, if the sequence approaches 0, then the limit, or then the series, if the sequence does not approach 0, if the sequence does not approach 0, then the series will have to diverge. Okay? So what does that mean? So again, it means what it says, right? It says if the limit as n approaches infinity of a sub n does not equal 0, then the sum from n equals 1 to infinity of a sub n diverges. Okay? The idea here being, again, if your limit of the sequence is something other than 0, that means you're going to repeatedly adding that number, whatever it is, and it's just going to make your value of your series either increase without bound or decrease without bound, right? Okay. There's another way we can put this, and that's using something called the contrapositive. You may remember hearing about the contrapositive when you were in like geometry, or if you've taken any like philosophy classes or anything like that, or you've learned any philosophy. Okay, it has to do with logic. These conditions. This is called a conditional statement. If something, then something. Right. This is your hypothesis. That's your conclusion, stuff like that. The contrapositive is logically equivalent to the contrapositive of a statement is logically equivalent to the original statement. So we know this is true, right? We already saw it up here. The contrapositive is if you flip the order and negate them. So in other words, if the sum from n equals 1 to infinity, well, the opposite of diverge would be converge. Okay, so if the sum of the sequence, or if the series converges, then we can simultaneously say then the limit as n approaches infinity of a sub n equals 0. Okay, these two things are logically equivalent to one another. If the limit as n approaches infinity of the sequence does not equal 0, then the sum of that sequence, the series, right, will diverge, for sure. If the series converges, then the limit as n approaches infinity of your sequence must be equal to 0. Okay? What we don't know, okay, what it does not mean, if the limit as n approaches infinity of a sub n is equal to 0, then the sum of n equals 1 to infinity of a sub n converges. Okay? This is a wrong or a false statement. It's not necessarily true. Okay? Because again, our tendency, right, and in math and other scenarios this is true, right, our tendency is to take this statement right here and make it say more than it means. If the limit is n approaches infinity of the sequence of a sub n does not equal 0, then the series, the sum of that sequence, will diverge. Like, aha, great, perfect. Okay, but if the limit is n approaches infinity of a sub n is equal to 0, that does not necessarily mean, and that's the key, right? Okay, so if your limit as n approaches infinity of a sub n is 0, that does not guarantee the series then converges. Okay, if the sequence, the limit of the sequence is not equal to 0, then you know for sure the series will diverge. But if the limit of the sequence is equal to 0, it doesn't guarantee that the series will then converge. Okay. So not equal to 0 for the sequence, guarantees divergence. Equal to 0 for the sequence, may show convergence, but may still diverge. Okay, so that's why we want to be careful there. Okay, this test cannot determine convergence. Okay, it's inconclusive if a sub n, if the limit is n approaching infinity of a sub n is equal to 0. Okay, that's the best we can say. All right, so then we've got two tests that we've kind of gone over, all right, and hammered, right? The first one we talked about was geometric. And there were two scenarios for a geometric series. Scenario 1, the absolute value of your common ratio is less than 1, which shows what? The series converges. And it converges to S equal to A sub 1 over 1 minus R. Option 2, the absolute value of R is greater than or equal to 1, in which case the series what? Diverges, and there's no further work need to be done, right? Because there is no sum. The sum is infinity or negative infinity, right? And then the other test that we learned just now is the nth term test for divergence. Okay, and again, I'm going to refer to it back to that. And that's why what we just talked about a minute ago, that's why I suggest you really refer to it as the nth term test for divergence and not just the nth term test. The phrase nth term test for divergence clues you in that this can only be used to determine the divergence of a series. It cannot be used to determine the convergence of a series. Okay? So if you use this phrase, nth term test for divergence, it will help clue you in about the fact that this can only be used to show divergence and it cannot be used to show convergence. Okay? So if in this case, right, now there's kind of two scenarios here. If the limit as n approaches infinity of a sub n, again the sequence there, does not equal 0, all right, if the limit is n approaches infinity of a sub n does not equal 0, we then know what about the series. The series will diverge. I'm running out of space. Okay. If, however, the limit as n approaches infinity of a sub n equals 0, what can we say? Nothing. Okay, inconclusive. And that's what I'm going to put here. Inconclusive. Okay. The nth term test for divergence can only give us divergence. It cannot conclude any convergence. Which is really frustrating, but it's the best we can do. Okay? So, A through F there are for you to try right now. Okay? That's where we're not going to do these together necessarily. I mean, we'll go over them at the end, okay? But these are for you to try right now, okay? So none of these are specified about whether they are geometric or whether they're not geometric. Okay, so this is where we start to develop the skill of, kind of like looking at a series and determining what to apply. Okay, what kind of technique to apply. Okay, so you're going to be using the nth term test for divergence and then any of the others, which is geometric here, to determine if the series diverges. Okay, so what I would like for you to do here is determine if the series diverge, and then also determine by what, say by what test you're determining that. Okay, you don't have to say if they converge, you don't have to say what they converge to. Okay, you don't have to say what they converge to. But then I'll kind of come around and help here as necessary. Actually, get my answers written down, maybe, and then we'll. Yeah. So like if you see, if you like for one of them, if you see like it converges, and you use the geometric series, you say like converges by geometric series test, or diverges by nth term test for divergence, right? And you better not use the phrase converges by nth term test for divergence. Better not. Because we can't use the nth term test for divergence to prove convergence, right? We just talked about that. So you don't want to do that. Sure, you can convince yourself, right? You want to be able to use it. Like, come on, it should work, but it doesn't. It does not work. Notice also in like the C and F here, okay, in letter C and letter F, these exercises, they are not written in like the nice summation notation. So you're going to want to write those in summation. Well, maybe you won't want to, but it will be helpful if you write them in summation notation, potentially, just to figure out what the sequence is and stuff like that. Okay, so. about the graph of natural log
Well, then it's still divergence.
as x approaches 0 from the right.
Well, then it's still a divergence.
Sure.
Because it's not 0.
Right.
I was still right.
Well, make sure you're right for the right reason. Right.
I was right by case.
Even when you're wrong, you can't help but be right, Lander. It's an impressive skill.
Why is the natural log of 0?
Because this is like, imagine the graph of natural log, right? I mean, you agree that that's it, right? So as we approach, like, we can't really get to 0. And at 0, there's an asymptote. But if you like imagine approaching 0, you're going to be going down and down and down and down towards negative infinity. So it's because of the asymptote. So
Makes sense. This stuff is so much fun. Because not a lot of this stuff blows.
yeah.
You literally just wrote it up there. See if you can.
You will when he takes off points.
Why would you take off points on the test?
While you were sleeping, you told us that we can't write on that.
I wasn't asleep. I just
Yes, you
was
were.
resting my eyes.
You were out.
I touched your hand. You moved my head and I was like, I thought you were just. Were you just like standing there?
No, I was like, I'm gonna walk back, and I initially went to do it.
You just like moved my hand. Yes.
Mario's like, I can't give up wrist control.
I can't.
So you snap back away.
That's Kim Senior for you in a nutshell.
I don't get to see
The graph right there.
The graph right there.
So,
Yeah, there you go.
natural log of 1 over n, right? If you imagine you're approaching infinity, so it's really natural log of 0 you're trying to take. So you're okay with that part, right? So the graph of natural log, you agree, looks like this, right? So 0 is right here. There's an asymptote at 0. But if you approach 0, this is going to be going down towards negative infinity.
Okay.
When's our next quiz?
I think Wednesday or Thursday of this week. I have to check. Can I make it Thursday?
No,
We'll
wait,
see.
what
I don't
day?
know. Wednesday or Thursday of this week. I'm not sure.
I work both days.
Yeah.
Well, I work tomorrow, so given that it's Thursday.
Work Tuesday, Wednesday, Thursday. I close Saturday and I open and close on Sunday. 45-hour work week. Probably not. I don't have my hours for it. They never required me to get one. And if they ever and they said that if it's ever an issue, that it's just volunteer hours. But it still goes on.
So I'm illegally working right now because I'm not technically employed.
You're
Because
paid under the table.
because all the is seasonal, they have to terminate their employees, and so right now we're basically
You're supposed to be terminated, but you're working and getting paid.
my paperwork for this season hasn't been for this season. So basically, I'm just like, so I've been able to log out. Like I don't know how I'm getting paid,
They probably just like write you down hours.
but I hope
We're just not keeping up.
Are you getting paid a lot though?
I work 4 times last week. So it's like,
What's up? I don't know.
Holly Hills Club.
Alright.
Well, the
I saw Mr. McCoy there.
I said this the bottom that gets bigger. That's the top. That's why. It would still be.
Wouldn't it be 1 over 10 plus 5?
No, because N always goes up. Yeah. So if you did N plus 1, it would be your first thing, since it starts at 1, it would be natural log of 2. Or, yeah, natural 1/2.
So that makes sense. There's only like 10 problems.
How many questions?
Bro, we're about to have like 50 problems, and it's gonna come to Sunday night, and everybody's gonna choose have said anything if White didn't like start talking. And then White created a separate one. Dude, I was laughing so hard.
It was like 9, and I was just like, yeah, I knew I'd written notes at because I'm like, super easy. And I was like, I'm just gonna text people and see if they can get me the phone. So that's what I can say. And then no one did, and why? Like, I was like, why was it? Yeah, why was it? I didn't do it. And I was like, again. I was like,
You feel like well, I was gone all weekend longer, but I had to work an open to close shift yesterday, so I was like, dude, I wish I could do it for you guys, but I don't get off work until 10. There's no one on the way.
God, he's going to bed.
I texted home and then I was like, yeah, I'm not doing it.
I was like, yeah, you bad.
Or sorry.
Oh, bad. I was like 5.
Michael, thank God you were. Michael, if you didn't reply to me, I would have stayed up all night working on that homework.
I was about to be like, yeah, I do want it tonight, because I was already up doing the each hour. So I was like, I just rather not get all that right now.
I was just like, I don't care.
Sorry, guys.
I was like, man, I feel like this is
Nah, it's like so
limit is not equal to 0, therefore, or sorry, the 0.
Oh, you just have like
0. Not, you got nothing. We can, it's not equal to 0.
Did I have to use my book?
It's 5.
Yeah.
I didn't do it yet. Now it's beyond.
Is that also
Divergence. If he will say that.
Is this really? Are you actually right about this?
Hold on.
Yes, I'm actually right about
I don't know, did I get
Of
it?
course I'm right.
You're going to need one
Aubrey, B. You should have rewrite it.
Friends,
B. You had to rewrite it 6 times over.
So I was like, Barnes and Noble. I got it on
It's like
RIP environmental.
Therefore,
I worked at Friday. I worked at Friday. What?
Just gonna wait till not.
Oh yeah. Yeah, what happened?
yeah, what was that about?
we were in the hotel room next to it, we were all in the COVID, and I texted the group chat, I'm like, through the, active door, and I'm like trying to open it, but ours is like jammed. Like, as he's trying to pull, I like gave up, and then her husband walks in, he's like, open the door. And then I like close it to, what's that thing called? Deadly.
Yeah.
You doing all right, Aubrey?
I don't, so, wait,
So
sorry.
I like close it to the his name walks through, just like,
letter B.
Did she send it in the line?
So,
oh,
this
saw you.
is not an nth term test here. You want to use, because obviously it's inconclusive, right? We don't know. But look at what's happening. You have 5 being raised to the nth power. So it's the same thing as, so let me show you this.
You all know about that? Yeah. It's cool. And I really thank you, Lord.
So right, it's a geometric series.
So do I still, so I don't do that at all?
You can do that, but like you said, it's inconclusive, it's not helpful. So we have to try some other tests to see if we can maybe still get it to work, right? Inconclusive doesn't like, we don't want to stop at inconclusive if we can maybe find another test to use to get more definitive answers. See what I'm saying?
Be like this.
Okay.
Like how it was 6 in that run.
No, you have to rewrite it. You have to rewrite it
Oh, so
6 times.
Yeah.
It's like 1 or 2 more minutes here. 1 or 2 more minutes, and then we'll go over these. Okay.
Dog. You a wee guy?
Am I a wee guy?
That is.
Like, I don't know. Actually, I don't know. Oh, I think I know what it is. What is it?
A wee guy? You play Wii?
Like the Nintendo Wii?
Nah, man, the Wii Switch, bro. Isn't that still Nintendo?
Wii U?
I never got to play the Wii U.
Not many people did. Not many people bought it.
I didn't play any. Well, I played Wii, like, at my mom's.
Did you buy Wii U?
I missed tennis.
My last Nintendo.
Tennis on the Wii was so much fun. Dude, I got professional bowling. What else? They have boxing on there too. Oh, I got professional boxing. I just love golf. Just going out on the nice tee course,
Or you had the Wii board, you could like just
drinking a brewski with the
What? Never had that?
Yeah,
Yeah, we fit.
It's not a thing. I work at a golf course and I know it's an 18, so.
Or you could run on it.
Sometimes they call that the bar.
Right.
Bar afterwards. Once we all meet up afterwards.
Right.
I feel like there's at least a place I've heard of that actually has like they call their bar the 19th hole.
It's sick. I still think it's just inconclusive.
Some people don't wait, that's why they have the drink girls that go around the carts and stuff like that.
Bev card? Yeah, because I'm pretty sure the bottom gets higher faster than
I don't know. You could be right.
D. I'm just trying to figure out how to explain it.
What?
D.
D? It equals 0. The limit equals 0. Which means
Okay,
it's inclusive.
letter A. Diverges or converges? Diverges by the geometric series test there. Okay, common ratio is 6/5, greater than or equal to 1, diverges.
But I still think.
Okay, letter A, diverges by geometric series test. All right, how about letter B, diverges or converges? Converges by geometric series test. That's right. Okay. Yes. Gabe?
So does it converge to 0 or does it converge to 1/5?
Okay, so good question, right? The answer is neither in this case. Okay, so let me talk about what's going on here. So this, what do we do here? We took the limit of the sequence. That means the list of numbers. If you put that list out to infinity, and eventually it's going to approach 0. The 1/5 is your common ratio, which you can then use to get the sum, the limit of the sum, right, or the sum, the infinite sum, by doing the first term divided by 1 minus r. Right? But we don't have to find the actual sum here, just as if it's converges or diverges, that's it. So, all right. Letter C, there it is. What do we say? Converges or diverges? Diverges. Okay, so there's this summation form for it. 1 to infinity of the natural log of 1 over n, or some people wrote it like, you could use like n equals 0 if you wanted to. That would slightly change your sequence there too. Either way, okay, the limit as n approaches infinity of the natural log of 1 over n approaches negative infinity, right? It's non-zero. The limit of the sequence is not 0, therefore the series must diverge by the nth term test for divergence. Questions on C? Okay. Letter D. What is this one going to do here? Diverge or converge? Ooh. Inconclusive? Not inconclusive. If you take the limit, of this as k approaches infinity, I guess I should say, as k approaches infinity, you will get infinity over infinity, right? Indeterminate form. But if you apply L'Hopital's twice, you'll end up with
Some random number.
you'll end up with this. Okay, your second application of L'Hopital, you'll get that, which that goes to infinity, not indeterminate form, not infinity over infinity, just infinity. And so therefore that's non-zero. And since the limit of your sequence as n approaches infinity or k approaches infinity, excuse me, is non-zero, therefore the series must.
Wait, can you show the first application of the test?
Sure. Right here. Excuse me. Okay, derivative of 6 to the k is 6 to the k times natural log 6. Okay. All right. Oh, question. Yes.
So can you just take the 6 and like the 6 to the k and multiply it to like the rest of it, like, you know, and then that would be like BR, and it would be bigger than 1, so then it would diverge. I didn't explain that well at all.
No, but I think it's not that I'm saying no. You didn't. I didn't explain it well. I'm just trying to see here. So you're trying to say, can we just kind of imagine it to be a geometric series here in a sense, or?
Well, cause like, you know how you can take the 6 on top and you can like make it so instead of being on top, it's just multiplied to the rest.
Oh yeah, like times 6 to the k. I got what you're saying. I think I see what you're saying there, and I think that would be okay, but I think like the reasoning that you would have to, the reasoning behind it might be a little bit tricky to explain, I think. But I think it would work, because really what's going to determine the term here, this k squared plus k plus 1 in the denominator is going to get completely dwarfed by that 6 to the k as k gets really big, and so then that 6 to the k, which is really like a geometric here, is going to be our determining kind of factor there. I don't know. I would still follow this route, but I see what you're saying there, and that could be okay though. That could be okay. So, yeah, and that might be. That actually is an application, I feel like, of something called the comparison test, and we'll look a little bit more at that later. So we might be able to answer that question a little bit more later too. Because what we're kind of arguing there is that the one we're given is always going to be less than 6 to the k, since, let me see here. Never mind then. If 6, we need to do it a different way. Yeah, never mind. That might not work with the comparison test. Never mind. Anyway, forget that. Letter E. All right, well, I can check on that too. So letter E, the series diverges by the nth term test for divergence. Okay. This one I didn't even bother applying L'Hopital's. I just did what Maddie was trying to allude to earlier about the same degree on the numerator denominator, 5/1. So then it's got to go to 5, which means not 0. Therefore, the series diverges. All right, and the last one, letter F, it. What? Converges. Is right. Converges. Yes. Okay, so it's helpful again to write that limit. Write the series out. The rule for the series. Series. Hurting. Okay, write that series out so that you can then see that the common ratio there is going to be -2/3, which is less than 1, so therefore the series converges by the geometric series test. Okay? Questions on any of that?
Cool beans, bro.
Cool beans. Cool beans, beans. All right.